Lecture 53 is Stoke theorem. That's the relation between the line and the surface integral. Now the Stoke theorem, a relation between the line and the surface integral. So if suppose S be an open surface which is bounded by a closed curve C, and we have a vector field, or we say a vector point function f, that is f1i, f2j and f3k, and having the continuous first order partial derivative, then the line integral of f dot dr is equal to the surface integral by taking the curl of that f dot n ds. So here suppose that's in if you see that figure, so suppose that's in curve C, say that's in curve C, or we can say that's in curve R, which is bounded by that curve C. If you are taking the xy plane, or if you take the xyz plane, the surface is like that. So that surface S, which is bounded by the curve C, that's in curve, suppose that's in curve C. So here if you want to evaluate the line integral and the direction of the f is on that region is like that, or on that surface it may be like in that direction, or it may be. So if you want to evaluate the line integral, so by the help of surface integral, by taking the curl of that over the given region or the surface, we can evaluate that line integral. Why we are taking the curl of that f? Because the direction of the vector on the surface may be changed, or it can be rotate, which is easily evaluated by taking the curl. So here you have to remember the Stoke theorem, that is in relation between the line integral and the surface integral. Or the another statement you can say surface integral of the component of curl. If you are taking the curl of the vector point function or the vector field along the normal to the surface, that is normal to the surface which is perpendicular, that is n cap, taking over the surface S bounded by the curve C, is equal to the line integral of the vector point function f taking along the closed curve. So that is the Stoke theorem. The line integral f dot dr is equal to the surface integral curl of f and ds. And now evaluate the line integral f dot dr by the Stoke theorem, where f is y square I plus x square j minus x plus z k, and C is bounded by a triangle of the vertices 0 0 0 1 0 0 and 1 1 0. Now here if you see the bounded region, if suppose that's in x, and that's in, we take y and z, so the coordinates are 0 0 0 1 0 0, so that's in the coordinate 1 1. If we take down the x and y plane, and this in origin 0 0 0, and this is 1 0. So here you see that's in the equation is what y is equal to x. So here the region is bounded by the line. If we say that's an origin O, A, and let's say B. So here the given condition, the z coordinate of each vertex. If you see this vertex, in each vertex z is what? 0. So therefore we can say that triangle lies in the xy plane, and in the triangle, or we can say the region is lies on the xy plane. So here when we take the xy plane, so we can say the unit vector along that plane is what? Z-axis. So the unit normal vector n cap is equal to the unit vector k. Now we evaluate the curl of vector f. The vector f is given, so we can easily find the curl I, j, k, and del upon del x, del upon del y, del upon del z, and y square x square minus x plus z. So when you evaluate that, so we get j and the I, that's become the derivative with respect to this is 0, this is 0. So when we take the j, so the derivative of that with respect to x is minus 1, and with respect to that z is 0, so we get minus minus plus, that's j plus 2x minus y k. So this is the curl f. Now the dot product of curl f with the unit normal, so j plus 2x minus y k dot product with the n cap, that is n is equal to the k unit vector, so we get 2x minus y. That's a value of curl f dot n. Now as you know, if you see the equation, so the line OP is what? Y is equal to x. So the line integral f dot dr we write as, by the Stoke theorem, the surface which is bounded by this curve C is equal to curl of f dot n ds, and we write curl double integral, the curl of f dot n is 2x minus y, and the ds, that is in the region, on this we write dx dy because that's in xy plane, the limit of x, so x is varies 0 to 1, that point 0 to 1, that's the limit of x, and y varies, we can say 1 up to 0 to x, that's one, so we say 0 to x, that's the limit of y. When you evaluate that integration, so we get 1 by 3. Here you just remember the x varies 0 to 1 and y is equal to 0 to x. So here you note we can verify, or we can easily evaluate that line integral by using the Stoke theorem.